Welcome to this session. So this session is based on polygon clipping algorithms. But before that, from the previous sessions, we have seen various line clipping algorithms. So till now we have discussed Cohen-Sutherland algorithm, Cohen-Sutherland. Then we have discussed Liang-Barsky algorithm. And one more algorithm that today we will discuss, that is nothing but midpoint subdivision algorithm. So this midpoint subdivision algorithm, it is simple algorithm which this particular algorithm is using concept from Cohen-Sutherland algorithm. Cohen-Sutherland algorithm. So which concept it is using means region codes. It is using region codes. I think we know, you know that suppose this is a window, the window will have region code 0000. Then there are various 9 different regions. This is left region, right region, bottom, top, like this. And you have to calculate 4-bit code, that is B4, B3, B2 and B1. So 4-bit code you have to calculate. Then how this midpoint subdivision algorithm works. Now see here. In midpoint subdivision algorithm, first of all, if suppose any line is given, line suppose AB we have, then suppose this is A and B, then what you have to do, you have to calculate region code for A and region code for B. So calculate region code for, region codes for A and B. So you will get some code, that is nothing but 4-bit code. For example, it is 10001 or it is 1000 and B is 0100. Consider it is like this. Then what you have to do, you have to find, as those lines, means as this A and B are having non-zero codes, non-zero code, it means that the line is not completely inside. You have to find ending of this, that is nothing but 1000 and 0100. What is the ending of it? That is 0000. It shows that line is somewhere clipped by window. Line is somewhere clipped by window. If suppose this ending is non-zero, it means that line is completely outside. Okay. So there are 3 cases. First case is if the region codes are 000, you have to accept the line as it is because the line is completely inside. Second case is ending is suppose non-zero, then line is totally outside. You have to discard this. And in third case, wherever ending is 0000, so this is nothing but line is clipping candidate. So you have to follow some different concept in midpoint subdivision algorithm than the Cohen-Sutherland algorithm. So what is the concept you have to follow? Suppose for example A and B is the line. A and B is the line. Now you have to, what you have to do, you have to find the region codes for A and B. Region codes for A and B. The region codes. Now after finding region codes, what you will find that the region code, suppose it is 10 or suppose 0001 and it is suppose 0 means 1000 for example. And then find out ending of it, that is 1000 and 0001. Ending is 0000. It means that line is somewhere clipped. Now what you have to do, in midpoint subdivision algorithm, divide the line into 2 equal parts. Okay, divided, that is nothing but A and B. It is divided at this location. Suppose this is C dash or C. Point is C. Now there are 2 line segments AC and CB. Line segments become AC and CB. Now what you have to do, already region code for A is available, that is nothing but 00, suppose 0001 and it is 1000. Now find out for C you will get 0000. So those region codes you have to find by using formula that I've discussed earlier. So region code. Now see, AC and CB are two different lines. Now for AC, find out whether both codes are 000. No, means find out ending. So 0001 and 0000. What is the ending? 0000. Means that this line segment is also somewhere clipped by the window. And go for this one again, 1000 and 0000. The ending is 0000. It means that again this line is somewhere clipped by the window. Okay. Now what you have to do, you have to again divide the line into equal parts. Now AC is divided into two equal parts. So somewhere here, suppose you will get the point that is nothing but D, point as a D, and this point you will get somewhere as a E. Okay. Now find out the region code for this D. D will be suppose 0000, and for E it is suppose 0000 you will get. Now from this diagram, as there are the line is completely divided into four parts. This is first part, this is second part, this is third part, this is fourth part, correct? Now check for first part, that is whether both are 00. No, means you have to find the ending shows that the line is somewhere clipped. Okay. Now go for DC. As the DC, the both the region codes are 000. See here, both the region codes are 00. So you have to accept this part of the line, accept this. Now DCE, both region codes are 00, accept this part of line. Now for EB, again the ending is 0, means this part is somewhere clipped by the window. So what you have to do, you have to again divide the part which is not completely inside the window. So that AD will be divided into suppose F, and this is divided as a suppose G. Now see, AF will be code as 0001. Okay, the D is 00. G is suppose 10000. Then as this part, you will get ending of those as a non-zero, means this part will be discarded. Okay, discarded. Now FD somewhere clip, again you can divide into two parts, and this concept will repeat till you will get completely outside part or completely inside part. So this is called as midpoint subdivision algorithm. See here, again you have to divide. Here is the green and red color, it is accepted. So this process will be continued till the complete inside part you will get. So this is called as midpoint subdivision algorithm. Are you getting what it is? Suppose this is a line. Okay, initially it is divided into two parts. Then the region codes ending is non-zero. Again it is divided into four parts. So this is suppose completely outside. So you will discard it. It can be accepted. It can be accepted. This is somewhere clipped. So you have to divide it again. After dividing, you can neglect this. Again you can divide into two parts. So you can neglect it. Again you can divide. So you can neglect this and you can accept this. So this is nothing but called as midpoint subdivision algorithm. This is the third algorithm of line clipping. And this particular algorithm is using Cohen-Sutherland line clipping algorithm concept of finding region codes, then calculating ending of them, and based on that you can decide whether the line is complete or the part of line is inside, outside, or clipping candidate. If it is clipping candidate, divide that part into two equal parts, then again calculate region codes and then check the conditions. So this is called as midpoint subdivision line clipping algorithm. Okay. Okay, now we'll discuss the polygon clipping algorithms. There are two algorithms, that is nothing but Sutherland-Hodgman algorithm and Weiler-Atherton algorithm. Now start from this. What is the need of separate polygon clipping algorithms? See, polygon means what? They are having edges. Edges means what? They are lines, correct? So that you can think that if you use line clipping algorithm, you can clip the polygons, but it is not the case, because if you apply, suppose this is ABC as a polygon. What is my polygon? Polygon is a closed figure. Okay, polygon is a closed figure formed by 3 or more than 3 edges. Now suppose ABC is the polygon. This is the polygon ABC, and you want to clip this polygon against the window. And if you apply line clipping algorithm, then what will happen? AB line, it is clipped somewhere, so you can say here it is A dash, so you will get output here A dash, then B you will get, then CB line will be clipped somewhere as a C dash, so you will get C dash, correct? And the line AC, it is outside, so it will be discarded, and because of that you will get A dash, B, C dash as a output. But remember, whenever you will clip the polygon, the output is also polygon. If suppose we are cutting the paper, it never happens that paper will be hollow, means only edges we will get. We will get the polygon after clipping also. Hence, this is the problem occurs. Because of that, we cannot use line clipping algorithm as it is for the polygon clipping algorithms. Hence, we require some separate polygon clipping algorithms. So there are 2 polygon clipping algorithms we will discuss. First is Sutherland-Hodgman algorithm. Sutherland-Hodgman algorithm. And second is Weiler-Atherton algorithm. Now there is a confusion between the names. Line clipping algorithm is Cohen-Sutherland and polygon clipping is Sutherland-Hodgman. Understood? So there is a confusion in the name of the algorithms. Now we'll begin with the Sutherland-Hodgman algorithm. Now in case of Sutherland-Hodgman algorithm, see, this is suppose polygon. This is polygon, and this is window with boundary. Suppose the left boundary, this is the left boundary, this is right boundary of the window, this is top boundary of the window, and this is bottom boundary of the window. Okay, so in Sutherland-Hodgman algorithm, what you have to do, you have to clip, first of all you have to clip the polygon against the left boundary. You have to clip the polygon against the left boundary. Once that is clipped, the output whatever you are getting, you have to provide it to right boundary clipping. Then you have to clip with against the right boundary. Now whatever output you will get, that you have to provide to bottom boundary for clipping with the bottom boundary. And then whatever output you are getting, that will act as an input for top boundary clipping. Means what? See here, in Sutherland-Hodgman, polygon is clipped against the left boundary using the rules. There are various rules. There are 4 rules that we'll discuss. The left clip output is clip against the right boundary. Then same process is followed for bottom and top boundary. Now see here, if suppose this is the object, you want to clip against the boundary or against the window, then whenever you are clipping it against the left, you will remove this part. Okay, you will remove this part. This will be input for the next right clip. This is the right clip where the right side or the object is clipped against the right boundary. Then it is the output, it is given to the bottom clip, then bottom side it will be clipped, and then it is provided to top clip, and then finally you will get the object clip against the window. So for clipping purpose, you have to follow few rules. So those rules are, if suppose A, B, C, D is the polygon, and if the line or edge is going from outside to inside, as A is outside the window, B is inside the window, whenever the edge is going from outside to inside, at that time save intersection point. This is the intersection point, that is nothing but B dash. Save intersection point and second point, that is nothing but you have to save B dash B. Now whenever the line Now BC is the edge that can be called a line. If the line is going from inside to inside, then in that case you have to save second point, that is nothing but C. So you have to save C. Now suppose the case is that the line is going from inside to outside. Inside to outside means C is D. So what you have to save? You have to save intersection point, that is nothing but C dash. So you have to save C dash. Now suppose if line or edge is completely outside the window, that is AD, then you have to save nothing. Now from this means all the this one, what you will get the output, that is B dash B C C dash. Okay, C C dash. Now that is the B dash B C C dash. So this is the thing, but the output you are getting after clipping the polygon. So those rules you must follow for all the sides. Means it will be for left, it may be for right, it may be for bottom, it may be for top. So those rules must be remembered. Those four rules means if the line is going from outside to inside, what you have to save? Intersection point and second point. If line is going from inside save second point. If line is going from inside to outside, what you have to save intersection point. And if line is going from out to out, you have to save nothing. So those are the rules, and those four rules you must apply for left clip. Then whatever output you will get, that is applied to right clip input as an input, and apply four rules. Then output whatever you are getting, it is provided to bottom clip, and here also you have to apply the four rules. And finally top clip also you have to apply those four rules. And then finally you will get the output of clipping the object against the window with the left, right, bottom and top clip. Okay, now we will have some problems also we can solve later. Now what are the limitations of Sutherland-Hodgman algorithm? The limitations of Sutherland-Hodgman algorithm is, this algorithm, it is best suitable for convex type of polygons. What is meant by convex and concave? We know the polygons are divided into two types, that is convex and concave. Convex type of polygons means the polygons in that if you select any 2 points, the line is completely inside the polygon, that is called as convex type of polygons. If suppose the polygon is like this, concave, any 2 points are selected, then some part of line is outside, so that is called as concave type of polygons. So this Sutherland-Hodgman algorithm, it is best suitable for convex type of polygons. But if you apply the algorithm for concave types of polygons, then it leaves the line joining the two polygons. Actually see, if suppose this is the object you have, okay, this is a paper you have, and you have clipped the paper by using the scissor. So at that time you will get, what is the output? The two separate parts, those part and that part you will get separate. There is no line. But if you apply Sutherland-Hodgman algorithm for such polygons in a computer, at that time you are getting a line connected that two polygons. Actually this should not be there, because whenever you will clip the polygon, this part and this part will be separated from each other, correct? So this is the limitation of Sutherland-Hodgman algorithm, and that limitation of Sutherland-Hodgman algorithm, it is removed by using this is the required output. Actually output, if you apply Sutherland-Hodgman algorithm, you will get the line. But what is the correct output? This is the correct output. Means if you clip this against the window, then those two parts must be separated. So this is the required output. And to get this required output, there are some modifications done, and that is nothing but the Weiler-Atherton algorithm. So some modifications in Sutherland-Hodgman algorithm are incorporated. That is nothing but new algorithm. That is nothing but Weiler-Atherton algorithm. Now in Weiler-Atherton algorithm, what you have to do? You have to follow the same process, like left clip, right clip, bottom clip, top clip, as per the previous algorithm. Only there are two changes you must use. The changes are, whenever the object, whenever you are moving, means in case of line, whenever you are moving from out to in this case you are moving in out to in, at that time follow polygon boundary. This is the polygon boundary. And whenever you are moving from in to out, this is in to out, at that time after clipping follow the window boundary clockwise, so that this object will be closed. Once it comes, it will be followed window boundary and the object will be closed. Similarly, whenever you are going from out to in, follow polygon boundary, and when you are coming from in to out, at that time at the intersection you have to follow polygon boundary, window boundary, and close the figure. So this is nothing but the Weiler-Atherton algorithm, or the two changes incorporated. Otherwise the algorithm is same whatever as a Sutherland-Hodgman algorithm, only two changes are incorporated. That is nothing but whenever you are moving from out to in, at that time you have to follow the polygon boundary, and whenever you are moving from in to out, at that time follow window boundary and close the figure in clockwise direction. Okay, now so this is about the polygon clipping algorithms. Those two polygon clipping algorithms we have. Okay, now we'll solve some problem based on Sutherland-Hodgman algorithm. Problem on example on Sutherland-Hodgman algorithm. Okay, I will solve the problem. Suppose you have to clip the polygon against the window. This is a window, and you have to clip the polygon. This is suppose polygon. This is the polygon. Suppose I will draw polygon with different color. Suppose this is the polygon as a ABC, and this is a window, and you have to follow, or you have to solve this, or you have to find the output by using Sutherland-Hodgman algorithm. Now what is the step one? You have to apply the left clip. Okay, left clip. Whenever you will apply left clip, this is the left boundary, correct? This is the left boundary. This is the left boundary. Now what are the four rules? If the line edge is going from out to in, at that time save intersection point. Suppose this is a B dash, so save B dash and B. Now second, for BC, it is going from in to out, so that you have to save the intersection point, that is C dash. So save C dash. Now for AC, the line is completely outside, so save nothing. Save nothing. So what is the output you are getting after first clip? Left clip, that is B dash B C dash. So you can draw it against the window. What is whatever output you are getting? Here is the B dash. Okay, it is B dash, it is B, and you are getting C. So like this. This is the output you are getting. C dash. Okay, correct. So this is left clip. Now this is whatever you are having, you can apply for the right clip. Apply right clip. Now in right clip, this is the right boundary, correct? This is the right boundary. Now C, check B dash B, it is inside, so that you have to save B dash. Then second point, you have to save B. Then B C dash, it is also inside, you have to save C dash. And C dash B dash means you have to save B dash. Once again, you can see here, if you are not understanding it, I will show you. Now see, for right clip, this is the right boundary. Right boundary, this is the inside, so that B dash B is inside the right boundary, so that you can save B. Then B C dash, it is inside the boundary, right boundary, so that it is C dash. Then C dash B dash, it is also inside, so that B dash. means you have saved B, C dash, B dash, means the same object you will get after right click. You will get same object after right click. The same object. Same object till this C dash, B and B dash. Now after that, go for bottom clip. Third is bottom clip. Bottom clip. Now see here, this is the bottom boundary. This is the bottom boundary. Now apply the 4 rules. Start with B dash B. B dash B, it is inside the bottom boundary, so that save B, save B. Then B C dash, it is going from in to out, so that you have to save C double dash, means intersection point. Save C double dash. Then for C dash to B dash, it is going from out to in, means you have to save intersection point. Suppose this is the B double dash. Save intersection point and the first point, that is B dash. So it will have B, C double dash, B double dash, B. So what will be the output? You can draw the output of it. You will have B here, somewhere here. Then you will have C here, C double dash. This is B. Then B double dash is here, B double dash, and it is B dash. So you will have the output like this. Okay. Now apply for top clipping, for top clip. So this is the top boundary, and you will find everything is inside. So you can save. Suppose B dash B, you have to save B. From B C double dash, save C double dash. Then from C double dash B double dash, save B double dash. From B double dash to B dash, save B dash. Okay. So this is nothing but output. You will get final output, that is B C double dash, B double dash, B dash, using Sutherland-Hodgman algorithm. So this is nothing but the example for Sutherland-Hodgman algorithm, how it is clipped. Okay. So remember, actually in a first iteration it is clipped at this location, not at this location, because it is the left boundary. This is right boundary, bottom and top boundary. Okay. Against that you have to solve. So this is nothing but how you can solve the problem. So we have completed this Sutherland-Hodgman algorithm, Weiler-Atherton algorithm. What are the issues of that, limitations of Sutherland-Hodgman algorithm, then what are the rules of it. So what is Sutherland-Hodgman, that is left clip, right clip, bottom clip, top clip. Then we have discussed what is the need of separate polygon clipping algorithm. Even there are line clipping algorithms. And in today's session we have discussed midpoint subdivision line clipping algorithm. So this is nothing but how we are having the algorithms. Now remaining part, that is nothing but character clipping, that we'll discuss later. Okay. So we'll stop here.